Hello everyone, welcome to this part of the question where we are required to factorize completely this following expression. So looking at it, I realized that I could make some rearrangement to factorize neatly. Okay, so I saw that 4n 4p square negative p square q square and negative q square. So I'm going to just rewrite them. And then I'm going to just factorize separately. Common factor is 4. I'm left with 1 plus p square and why is there a 1 there? Because I do need to make sure that when I expand out the bracket, I must get back my terms. So 4 times 1 is 4 and 4 times p square is 4p square. Okay, so in the other two terms, I will have negative q square out and I'm left with p square plus 1. One plus p square plus 1. They are the same. Therefore, I am going to take them out as the common factor. And I have 4 minus q square out. And I pause for a while because I realized that, hey, can I factorize 4 minus q square? And the answer is yes, because 4 minus q square can be written as 2 square minus q square. Meaning, I could continue to factorize them, okay, using the algebraic special product of a square minus b square equals to a plus b, a minus b. So the final answer for this will be 1 plus p square, 2 plus q, 2 minus q. And we have come to the end of this part of the problem, and let's move on to solve other problems.